Hi, this lesson is really a lot of vocabulary. 11.1 Part 1. It's called the Geometry of Solids. So it's the first lesson of the chapter just to establish some vocabulary. So first we have a polyhedron. Definition: a solid, so all those are solids, formed by polygons that enclose a single region of space. So inside each of these, you can see that there's a bunch of space inside there. And that's enclosed in a single region of space. A solid formed by polygons. This is formed by triangles over here. This has more triangles. This has pentagons. This has squares over here. This one has rectangles on the sides and hexagons on the top and the bottom. So all of those polygons get together and they form a solid region of space inside. That's called a polyhedron. So the parts of the polyhedron, the face. So you can see the face here is this whole triangle on the side. There's another triangle, another triangle. Those are all faces, the flat polygonal surface of a polyhedron. The edge is where two faces intersect. So right here, this one and that face, those two faces come together at that edge. And the point of intersection of three or more edges. So where the edges come together at these points, those are called vertex points or vertices. They are classified by the number of faces. If it has four faces, it's a tetrahedron. If we were in school, you would be having a quiz, and one of the questions on the quiz was always draw a tetrahedron. So here would be the tetrahedron type figure that you would have to draw in that quiz. So see how it has four sides? It has this bottom, and then it has one, two, side, left side, front, and then there's a back. So there's four sides there. Okay, this has six sides, hexahedron. You can see how different they look. Both of those are hexahedrons because if you count the sides, there are six in each of those. Same thing here, heptahedron. They each have seven sides and they look totally different. Here's a decahedron, has 10 sides, and a dodecahedron has 12 sides. Regular polyhedrons. Each face is enclosed by a regular polygon. Each face is congruent to the other faces, and the faces meet at each vertex in exactly the same way. So like for instance, this cube here is made up by congruent four-sided figures called squares, and they all meet at these vertices in the exact same way. This guy over here is made by pentagons. Every one of those is a congruent pentagon. And they all come together to form that polyhedron, and when they meet at the vertex points, they always meet in the same way. There are different types of polyhedrons. One of them is a prism, a special kind of polyhedron with two faces called bases that are congruent parallel polygons. So for instance, here on the top there is a rectangle, the bottom is a rectangle. Those are the two bases. Here, that's called then the rectangular prism. The next thing probably says that's how we name them. Where does that say? They're classified by the shape of the bases. So these bases here are parallel to each other, congruent to each other. They are triangles, so that's a triangular prism. And this guy here has a hexagon on the top and a hexagon on the bottom, parallel and congruent, and those are called a hexagonal prism. That's called a hexagonal prism. There is a right prism and an oblique prism. Okay, see the difference. In the right prism, it has lateral faces that are rectangles. So all of these faces in here are rectangles. Okay, here, these are not necessarily rectangles. It's a parallelogram, but not necessarily a rectangle. The lateral edges are perpendicular to the base. So this edge here is perpendicular to the base. This edge here, perpendicular to the base. Okay, over here, the edges are not necessarily perpendicular to the base. Look at this. It's not perpendicular to the base. This is perpendicular to the base, but that's not an edge, that's an altitude. So the altitude of a prism is a perpendicular segment from one base to the plane of the other base. The height of the prism is the length of that altitude. So here they're showing me an altitude. Here they're showing me that in an oblique prism, you can have altitudes that are outside of the object itself. There's another polyhedron called a pyramid. You all know these. You probably learned them on Sesame Street or wherever. It has one base. And the shape of that base is what determines the name of it. So on the base here, this is a trapezoid, and so they call it a trapezoidal prism. The base here is a hexagon, so that's a hexagonal prism. Here's a square at the base, so it's a square hexagonal pyramid, square pyramid. Now, pyramids have these sides that are triangles. See how every one of these pyramids has these sides, these lateral faces that are pyramids. Then we have solids that have curved surfaces, and the first one they talk about is a sphere, the set of all points in space at a given distance from a given point. So here's the given point, and then you have these points all the same distance from that one center point. The given point is called the center, the given distance is called the radius, and now we take that same sphere, cut it in half. It's now called a hemisphere. It has a circular base, and that circular base is called a great circle. And we've already talked about cylinders when we were talking before about surface area. We did a lot of stuff with cylinders, so they just bring this back. Has two bases that are circles. The bases are parallel to each other. The bases are congruent to each other. There's this thing, we didn't talk about this before, an axis is a segment that connects the centers of the bases. So this is a right cylinder. That axis right there is perpendicular to the base. The radius of the cylinder is the same as the radius of its base. A right cylinder, the axis is perpendicular to the base. See in an oblique, this axis that I have here that connects the center here to the center there is not at a right angle. So that's what is another indication that that is not a right cylinder but an oblique cylinder. And then to talk about the altitude again, keep talking about the altitude and height. It's the same in all of these figures. And then this is the last kind that we're going to talk about. Geometric solids with curved faces, the cone. We've already talked about the cone. Remember, surface area is pi r L. Remember that? So a cone has a circular base. It has a vertex. It has a radius, which is the same as the radius of its base. It has an altitude that goes from the vertex perpendicular to the base. Here, from the vertex perpendicular to the base, or an extension of it. So in this case, again, when something's oblique, that altitude could be outside of the figure itself. There are right cones and oblique cones. You can see that right there. So that's just the introduction into Chapter 11. I didn't really have a whole lot to say about it. You can kind of look at the notes for this one and look to see what these are like. You can also look in the textbook. The textbook also has these same kinds of pictures to look at. Hope you are doing well.